This is a demonstration and discussion of the operation of the hybrid system of the first generation Honda Civic Hybrid. The Honda Civic Hybrid first started in the 2003 model year, and the system is unique in that it uses what Honda calls an integrated motor assist system. So we're here looking underneath the hood of this 2003 Honda Civic Hybrid, and you can see the orange cable housing in the engine compartment. It actually comes up from down below where it comes from the back of the car, where the battery is, and comes up and goes in between the 1.3 liter engine and the CVT transaxle that is used in this integrated motor assist system. I have a separate video on CVT operation on YouTube on the Weber Auto channel if you want to check out CVT operation. But the integrated motor assist system is unique as far as hybrids are concerned, because we use a typical internal combustion engine. This one is a Atkinson cycle engine, so it's a little more efficient at the higher RPMs than at the lower RPMs. But then, as you can see, this orange cable that we have here on this engine stand is the same orange cable as we have here underneath the hood. And that cable comes, and it's three-phase AC voltages with the U, W, and V phases connecting to this electric motor assembly that's bolted to the back of the crankshaft. The silverish metal part in the middle is the IMA rotor, and it bolts directly to the crankshaft, as you can see. And then all those coils of wire, there are 18 coils of wire, are used for the three-phase motor operation that helps turn that center IMA motor. That IMA motor has 12 permanent magnets attached to it, and if we zoom in close here, the permanent magnets are red in color there. So right next to the coil of wire right here, we have a permanent magnet right there. But as I said, we have 18 coils of wire and 12 magnets. So with proper timing of this DC brushless motor, which is also called an AC synchronous motor, we're able to assist the crankshaft in rotating. We also have position sensors right here for an reluctor wheel that bolts to the back of the crankshaft, and we've removed that so that you can see the motor assembly. This motor assembly is just a couple inches wide, as you can see here on the back of the motor. Just from here to the back is the IMA motor assembly, and Honda calls that assembly the power drive unit, the PDU, power drive unit. And so we've got electrical connectors right here for the position sensors, and the three electrical connectors right here for the three-phase cabling that comes from the back of the vehicle. This cable, if we follow it on the car, it leaves the power drive unit in between the engine and the transmission and goes underneath the car. And you got to be careful when you lift this car, because the metal bracketry that protects this cable underneath the car is very near where the hoist lifting points are. So we have to be careful not to damage that as we lift this vehicle on the hoist. But if we come to the back of the back seat area of the car, we have removed the back seat, and what we've exposed here behind the back seat is called the intelligent power unit. This entire assembly going across there is called the intelligent power unit. Well, if we look closely right down here, you can see the three-phase cables, the U, V, and W wires that come all the way from the front of the vehicle there at the power drive unit. So the three-phase cabling starts here and goes to the front to help the IMA motor drive the vehicle. So there's a cover that covers this up behind the back seat. I want to show you that cover. This is the cover right here, and this cover has another cover on top of it with these two bolts that we have to take out. And when you take those two bolts out, there'll be a switch, just like a wall switch, to turn the lights off on and off on the wall. And that switch is to turn on and off the high voltage system, DC high voltage system that's behind this panel. Now, of course, we're dealing with high voltage here. I want to zoom in and have you see this warning label. Warning, high voltage, you will be killed or hurt. Do not remove this cover. No customer serviceable parts inside. You should be a trained Honda service technician to remove this cover, but there are service technician replaceable parts behind this cover. You do not have to replace the entire power drive unit assembly. And then, of course, there's if you need to dispose of the battery, it has disposal information here also. But since I am trained in Honda IMA systems, I've removed that. We use the personal protective equipment that you should on any hybrid vehicle with high voltage, the class 0 gloves and the over gloves, and making sure that we don't touch any orange cabling unless instructed to do so, and then also not doing that unless we've taken voltage measurements to make sure that there's no voltage on those cables before we disconnect them. So what we're looking at here in the back, or behind the back seat, over here on the right, that big black unit right there is the high voltage battery. This is a 144 volt battery. There are 120 1.2 volt nickel metal hydride cells in that battery, and they are connected, as you can see, those two cables right there with the plus and the minus. That is our high voltage DC output that goes from the battery over to this big assembly right here, which is called the motor power inverter assembly. And the motor power inverter assembly, this module back behind there, that black piece, is an insulated gate bipolar junction transistor, IGBT driver from Mitsubishi. It's called, from Mitsubishi, it's called an intelligent power module. But it's going to take that DC voltage and current from our high voltage battery and invert it into AC, and then drive the three-phase cabling and motor at the front of the vehicle. And so this whole assembly right here is the motor power inverter assembly, along with the motor control module, that computer right there. We've got some small wires coming in on the top and more on the bottom. That's the motor control module that's in charge of the intelligent power module, which drives the three-phase cabling. Also, while we're here, you can see that we have two other small cables, an orange one and a black one, coming out of the battery module. So that whole battery is called the battery module. but those two come out and go into a module underneath the battery control module, and that is our DC to DC converter. So those two cables are high voltage, 144 volt, that go into the DC to DC converter, and then this red cover and that black cable are actually connected to the battery positive terminals. The red terminal is connected to battery positive, the black terminal is chassis ground. But that is our charging system output that keeps our 12 volt auxiliary battery charged, and of course the rest of the car runs on the 12 volt system. This high voltage system is only used for driving and controlling that power drive unit between the engine and the transaxle. So once again, we have a high voltage battery, and then DC battery. We have the DC cables that come into the motor power inverter that's controlled by the motor control module. The DC is inverted to AC that goes up front to drive the motor to help the crankshaft turn and improve fuel economy. On this first generation motor, this battery is a 6 ampere hour battery, and the motor assembly is a 10 kilowatt output. If you recall, there's 746 watts per horsepower, so it would take 76,400 watts to equal 100 horsepower. So 76.4 kilowatts is 100 horsepower. This is 10 kilowatts, so roughly about a seventh of that, so 12 to 15 horse, somewhere in that range. I should have done the calculation, but I didn't. So it assists and helps the improve fuel efficiency, better fuel economy, better emissions. Now also, during deceleration, when the motor is being driven by the transmission, like going down a hill, then that motor unit on the IMA motor unit on the back of the crankshaft then becomes a generator and helps to provide three-phase AC power back to our inverter converter assembly, and then it's converted to DC to recharge the battery. So we can accelerate and draw power out of the battery, DC, change it to AC, drive the motor. When we decelerate, then we'll use the AC power generated by the spinning magnets there on the rotor assembly to create AC voltage, just like an alternator with the three-phase cabling, where it goes back and is converted with a full wave rectifier into DC and stepped down to charge the DC battery. All right, so the cables, as far as what you need to look out for, these three cables, they are very dangerous to mess with or unbolt or do anything with if the engine is running or if the vehicle is being towed and if the key is turned on. But if the key is off and the engine is off, since this is AC voltage, there should not be any voltage at all on those cables, and you shouldn't have to worry too much about it. But never make that assumption that it's okay to touch without taking a voltmeter, AC voltmeter, DC voltmeter, and checking to make sure that there's no voltage on them before you unbolt it. Let's say you had to change the engine in this vehicle. You're going to have to unbolt those wires. You need to know when it's safe to unbolt those. There's also a special procedure to come in and pull out this IMA rotor assembly. It takes a special tool with guide pins. Those magnets are extremely strong, and the air gap between the rotor and the field coils is very small, and if you try to pull that off without the special tool to keep it guided coming off, you could damage the rotor and motor assembly. Alright, now I'm going to show you the power disconnect switch on the battery assembly. I forgot to show you that. So we'll come back here to the driver's side of the battery. So here's our battery, and right here in the middle you can see that switch that's on off, and if I can reach my hand in, it's off right now. Now it's on, now it's off. The switch is not in a location where anyone is going to be able to quickly get to it in an accident. And so you need to realize that on the side of that battery, on this side right here, are some relays that for high voltage systems are actually called contactors. And what happens is the 12 volt system on this vehicle and the motor control module and the battery controller will control those relays to open circuit those two 12 volt wires, or not 12 volt, those two orange high voltage wires, the 144 volt wires. So even if that power switch were on, let's say I flipped it to the on position right now, unless the contactor relays are closed on the side of that battery pack, there will still be no voltage on those wires, and those are controlled by the 12 volt system. So what I'm saying is, in an emergency, if you're an emergency responder or you're worried about high voltage dangers, the way to totally disable the high voltage system is to come up underneath the hood to the 12 volt battery and disconnect it. And if you're in a big hurry, like emergency rescue personnel, just cut the negative and positive cables. That will kill the power to the modules that control those contactors on the battery pack, and those contactors will stay open. If they were closed, they should open, and that will open circuit the high voltage system anyway. So these orange cables under the hood here on the Honda, there's no power in them right now, and so it's safe to touch the housing. You're not going to hurt anything. But once again, don't make any connections or disconnections unless you have been properly trained with the high voltage personal protective equipment, the gloves and so on. Using a multimeter, make sure that you have no voltage on anything before you disconnect it. But you don't need to be so scared to work on these things that you don't work on them, because the majority of the time, even though the cables are orange, if the ignition is off and the key is out, there's no power on any of those wires anyway. In most cases, it is possible that if a contactor relay were stuck closed, that it could trigger or it could still have power on one of the wires, but that would typically trigger a trouble code. Now let's talk about the cooling of this intelligent power unit back here. This is an air-cooled system, and if we look right up here on top of the speaker shelf, the rear deck here, that's the air inlet for the cooling system. And the air is drawn in, it comes through the battery, goes across the DC to DC converter and our motor power inverter converter assembly. And let me open the trunk and we'll look in there. Here in the trunk area, you can see the inlet right here from the vent system on the speaker shelf, and then it goes in to where the battery is, and then over, as long as that cover is on that we pulled off, It comes over and we have an electric motor assembly. See if I can get some better view of it. You can see the squirrel cage right back there. That electric motor assembly is going to blow the air into the trunk, where we've got the little damper doors where it can exit the vehicle. So we're going to pull in the either heated air or air conditioned air from the passenger compartment, because the battery doesn't like to get hot. So if it's a hot day, you'll probably have air conditioning on, and it'll pull in cooler air to cool the battery. If it's a cold day, then you'll probably have the heater on, and it'll help pull warm air in, because the battery doesn't like to operate when it's cold either, and that'll help warm the battery up. And we don't want to put coats or blankets or anything over that air inlet, or it could cause the whole system to overheat and shut down, which of course would cause some problems. So this has been a demonstration and discussion of the overall operation of a 2003 Honda Hybrid electric vehicle. This is the first generation Honda Civic Hybrid. There's a second generation that had a 15 kilowatt output and much more efficient and lighter. And then the third generation just came out for 2012 that actually uses a lithium-ion battery pack and has a 20 kilowatt output IMA motor assembly there between the engine and the transaxle. So it's getting better and smaller and lighter and more fuel efficient. And of course, with the corporate average fuel economy requirements being increased for the years coming, vehicle manufacturers have to do something to improve the fuel economy of all their vehicles, and I'm glad to see these improvements being made in the Honda Civic Hybrid, which I think is a great vehicle. We have this vehicle here at Weber State University in our Automotive Technology Department as part of our bachelor degree in advanced vehicle systems, and this is part of the Honda Pact bachelor degree option that we have here at Weber State University. We're one of the only schools in the country that has a partnership with American Honda for a bachelor degree, and we also use Honda natural gas vehicles and teach management training classes and alternate fuel classes using Honda products. This is, once again, this has been a demonstration of the hybrid system of a 2003 Honda Civic Hybrid.